Hello everyone, this is Professor He again. Nice to see you all. The topic of this subtask is about the first law of thermodynamics. The first law of thermodynamics, also known as the conservation of energy principle, provides a sound basis for studying the relationships among the various forms of energy and energy interactions. Based on experimental observations, the first law of thermodynamics states that energy can be neither created nor destroyed during a process. It can only change forms. Therefore, every bit of energy should be accounted for during a process. Consider a system undergoing a series of adiabatic processes from a specified state 1 to another specified state 2. Being adiabatic, this process obviously cannot involve any heat transfer, but they may involve several kinds of work interactions. Careful measurements during these experiments indicate the following. For all adiabatic processes between two specified states of a closed system, the net work done is the same regardless of the nature of the closed system and the details of the process. We consider some processes that involve heat transfer but no work interactions. The potato baked in the oven is a good example for this case. As a result of heat transfer to the potato, the energy of the potato will increase. If we disregard any mass transfer, the increase in the total energy of the potato becomes equal to the amount of heat transfer. We all know that a rock at some elevation possesses some potential energy, and part of this potential energy is converted to kinetic energy and the rock force. Experimental data show that the decrease in potential energy exactly equals the increase in kinetic energy when the air resistance is negligible, thus confirming the conservation of energy principle for mechanical energy. The following topic is about the expression of the first law of thermodynamics. We use these symbols for different energies. Keep in mind that the total energy is the summation of internal, kinetic, and potential energies. For a general system, the system changes during a time period, including interaction of mass, thermal energy, and work with the surroundings. The initial state is, the intermediate state is, the final state is. According to the law of mass conservation, the change of mass in thermal system is equal to the difference of inlet mass and outlet mass. In the light of the preceding discussions, The conservation of energy principle can be expressed as follows. The net change in the total energy of the system during a process is equal to the difference between the total energy entering and the total energy leaving the system during that process, or the sum of the energy added to the thermal system minus the sum of the energy output from the thermal system equals the increment of total energy of thermal system. We got the differential form of the first law, and it is equation 2, 3. The integral form of the first law is equation 2, 4. Equations 2, 3 and 2, 4 are the fundamental expressions of the first law of thermodynamics. They are applicable for any thermal system, any working fluid, any process. Let's talk about the expressions for the special cases. The first is the energy equation of closed system. For a closed system, see the figure, of the piston cylinder system, the initial state is 1 and the final state is 2. That is, the piston cylinder system undergoes a process from state 1 to state 2. The initial internal energy of the system is the heat addition during the process from stage 1 to 2 is the expansion work to the surrounding during the process from stage 1 to 2 is the final internal energy of the system is. There is no change in kinetic energy and gravitational potential energy. Most systems encountered in practice are stationary. That is, they do not involve any changes in their velocity or elevation during a process. No mass is exchanged for a closed system. Substituting the above conditions to equation 2, 4, the integral expression of the first law for a closed system is: for 1 kilogram working fluid, the differential expression of the first law for a closed system is. They are applicable for closed system, any working fluid, any process. For a closed system undergoing a cycle, its initial and final states are identical, noting that a closed system does not involve any mass flow across its boundaries. The first law for a cycle shows that the net work output during a cycle is equal to the net heat input during a cycle. Okay, that's all for this task. Thank you very much and see you next time.